In this lesson, we're going to talk about matter. So matter is anything that has mass and takes up space. For example, a dime that can be made of silver and other metals, air that's made of nitrogen, oxygen, argon, and carbon dioxide, fire that is a mixture of different gases, smoke, it's a collection of tiny solid and liquid and gas particles. And then over here, you've seen a different color, heat and light. Those are in a different color because those are considered energy, not matter. So now we need to classify matter. Matter can be broken down into a pure substance or mixtures. For a pure substance, you'll have elements. These appear on the periodic table, such as silver, sodium, and carbon. There's also compounds. In compounds, the substance composed of two or more elements in fixed proportions, such as salt, which is NaCl, sugar, C12H22, oxygen 11 or O11, and carbon dioxide, CO2. For mixtures, we have homogeneous and heterogeneous mixtures. Examples for homogeneous mixtures, one is tea. Tea is a solution of compounds in water. Another example, milk. Milk is water, lactose, fat, protein, and minerals. Blood. Blood has plasma, white blood cells, red blood cells, and platelets. For a heterogeneous mixture, examples are pizza. Pizza has different distinct layers, such as the toppings, the cheese, the sauce, and the crust. Concrete, that's composed of sand, water, gravel, limestone, granite, all mixed together. And brass. Brass is composed of more than one type of metal. So copper and zinc are the most common metals in brass. Here's a visual representation of how we classify matter. Let's look at the elements first. So with these green circles, so some green atoms here, this example we can just say is maybe like sodium. That's from the periodic table. These two blue circles fused together, that's an example of what's called a molecule, or a molecule of an element you'll hear also. So for example, oxygen, O2, that's how oxygen exists in nature, paired together, two oxygens together. Compounds. So compounds, again, are a substance of two or more elements that are fused together in fixed proportions. Example, water, H2O. We can say the pink circle here is the oxygen, and then the orange circles are hydrogen. And then next example, you can say this is NaCl. Let's say the green sphere is sodium and the yellow one is the chloride for NaCl. For the homogeneous mixture, we have two atoms in this top example that are mixed together evenly. In this next example, we got atoms and also molecules. Those are evenly mixed together. In this last example, we have compound and molecules that are also evenly mixed together. For a heterogeneous mixture, you're going to have, again, those distinct two layers or multiple layers. So for this top example, we have this yellow compound, and then on the bottom, another compound. that can represent on the top oil and the bottom water. You can see two distinct layers when you try to put them together. On this next example, we have the blue atoms and the red atoms. Again, they're two distinct layers, so it's a heterogeneous mixture. The states of matter are forms in which matter can exist. Let's start with the solid state. In solid state, molecules constantly vibrate, but they cannot move around. A solid retains its shape and size regardless of its container. An example of a solid is ice. Now, if we go from solid to the liquid state, which we call that melting, the liquid state molecules that are able to move around can flow around each other. A liquid has a definite size, meaning a volume, and contains shape depending on the container it is placed in. An example of a liquid is water. Now, when we go from liquid to gas, we call that evaporation. With the gas, molecules move around really quickly and randomly bounce off and hit each other. It has no definite shape, no definite size, so it will fill up whatever container it's going to be put in. An example of gas is steam. Maybe you'll see that coming off one of your hot drinks you like to have, like tea. Now we go from a gas to solid, we call that deposition. With deposition, water vapor makes ice patterns on your cold windows. Therefore, you'll see frost on the windows. Now, if you reverse that and go from solid to gas, that's sublimation. You see that with dry ice. If we go from gas to liquid, remember that's condensation. And then liquid to solid, that's freezing. The reds representing adding energy, and the blue removing energy. Now we look at the fourth state of matter. That's called a plasma. So plasma has what are called ions, or basically those are charged particles that are positively, negatively charged. And those are moving around extremely fast, like the gas would. So examples of a plasma are the sun, lightning, and even a neon sign. When we go from gas to plasma, we call that ionization. And when we reverse that from going from plasma to a gas, we call that deionization. Physical changes where the physical properties change, but no new substance are created. Examples: boiling water, a haircut, breaking glass, slicing bread, or dissolving sugar in water. They'll still remain sugar and they'll still remain water. They're just mixed together. For chemical change, chemical bonds are broken and reformed to create a new substance and generally cannot be undone. Signs of chemical changes are a color change, gas being produced, such as bubbles, odor appears or changes. For example, when your eggs rot, they'll get a bad smell. Energy is absorbed or released. Think about something getting hot or cold. Or precipitate forms. With the precipitate, you'll have a solid that sells out of a liquid mixture. Examples of a chemical change: rotting apple. So when an apple rots, it undergoes a chemical reaction called oxidation. It is using oxygen from air to actually do this chemical reaction. The same happens with iron rusting. When iron rusts, it goes from elemental iron on the periodic table to iron oxide. And iron oxide is the chemical name for rust. With burning wood, also is oxidation. The carbon in the wood reacts with oxygen, and that creates ash and smoke. And baking a cake. So with baking a cake, you got the baking soda and the baking powder. When heated, that's going to release a gas, and therefore that's going to cause your cake to fluffen up. And digesting food. So when digesting food, you have the stomach acids are going to be breaking down the food in your stomach, and that's a chemical reaction, and it's not going to be undone. That's all I have for this lesson. Make sure to subscribe and hit the like button and leave a comment below.